Welcome to the first and one of the most important lectures of our course, Thinking in Graphs. Many times you can solve a problem faster if you just know what the graph of the function looks like. Remember, I have a lot of material to cover, so I'll go through it fast. I might be talking for 3 minutes, but this is a 30 minutes lecture in real life. Stop the video as needed. That is the beauty of an online course. What happens to the graph if we replace all the x's by minus x's? We are reflecting the graph over the y-axis. An even function is invariant under this reflection. Easy to remember since x to the power of an even integer is an even function. If we multiply the entire function by minus 1, we are reflecting over the x-axis. A function invariant under this operation is odd, right? Wrong. Only the zero function acts that way, and it is trivial to see it by the graph of the function. Reflection over both axes is the same as 180-degree rotation. A function invariant under this operation is odd, like odd powers of x. Reflection over the y equals x line is in fact taking an inverse of a function. Remember to always double-check the domain of the inverse, which is often different from the original domain of the original function. Note that in the subject math test, log denotes the natural logarithm. If we are using another basis, it should be clear from the context. Now, we will go over a few super important inverse functions. Notice how arcsine is the reflection of sine. The domain is from minus 1 to 1, and the range is from minus pi over 2 to pi over 2. Try to draw it yourself. This is important. Arc cosine seems strange, but it is the reflection over the y equals x line of cosine. The domain is still minus 1 to 1, but the range is 0 to pi. Oh, the beloved arc tangent. It has asymptotes at plus minus pi over 2 due to the behavior of the tangent function. The test authors love this function since it is smooth, it has all the derivatives, and strictly monotone, i.e. the first derivative is positive for all x's. But it has a bounded limit at infinity. Fun function. Quiz. Stop the video now and take 2 minutes to solve this question. By the way, all the questions you are going to see throughout this course are exam-like questions. Come back when you are ready. Ready for the answer? The answer is B. And the arctangent function eliminates all the other options. Remember that sine is bounded by 1, so if we are multiplying it by a function which is decaying to 0 at infinity, we still get 0 at infinity.